There's been interest of late in the idea of providing optical flame detection for waste disposal and waste sorting facilities, similar to the one that I have a simple 3D mock-up of right here. In this particular facility that we're looking at, you have a vehicle door here where trucks can come in, unload their back load into this unsorted trash bin, and then leave through this door. We have a few different pedestrian entrances. You have a backhoe or a piece of heavy machinery here that scoops up the unsorted trash and dumps it into a hopper here, where we have a trommel and a conveyor system that then takes it through this second-story structure, and the different bits of trash get sorted down into sorted trash bins. And there's some additional trash bins over here along this wall and over here, where the trash has been sorted down and it's going to be sent on to other facilities for recycling or further processing. So this is kind of an interesting facility because we have the potential for temporary obstruction in large moving objects like the heavy machinery, the vehicles coming in and out. We have a large pile of trash that could potentially have things like batteries and such that could start fires within this bin. And if you have a problem with your sorting or something gets into one of these bins that shouldn't be in there, you could have a fire in any of these sorted trash bins. And you could also have a fire on the conveyor system or in the trommel area. So the question becomes, how do we provide protection for this facility? How do we give rapid alarm response for this facility in light of these hazards? And the design that we arrive at tends to focus on the idea of providing coverage for these large inventories of potentially combustible materials that we're going to look at here, where my approach in this was to take the MicroPack FDS303 on the standard sensitivity setting, and we are trying to provide coverage with alarm and control action distances of 1.5 and 3D, where D is the effective detection range of the detector for a 40 kilowatt fire. And so what we're basically saying here is that we ideally want at least one detector to be able to see the entire building, because we've graded the entire building. But we want at least one detector to be able to see a roughly 100 kilowatt fire anywhere in the building. And so with that goal in mind, I put detectors here and here. And these are trying to provide good coverage to all sides, mostly of this large central unsorted trash pile, and to provide some coverage for the trommel and the start of the conveyor system. Then I add another detector here, which is mostly tasked with providing coverage for this area right here, where the client has indicated that they will sometimes or frequently have a pile of sorted trash or rubbish over here. And then finally, we have detectors 4, 5, and 6, which have been provided to mostly cover the sorted trash bins and the conveyor system. And having set that up and all the detectors turned on, we have our assessment shoebox, which I can show here, which I've made sure to cover the entire building, even though it's at an angle. And I've set it up with 14 assessment slices, and it goes up to a height of about 6.5 meters, which roughly corresponds to the top of this second-story sorting structure on the conveyor system. And just run the assessment. And having done this, we can show that with 6 multispectrum infrared detectors on their standard sensitivity setting, downvoted or downgraded to 75% sensitivity to account for the potential for them to be a little bit dirty or dusty, we can see that we can get 80% of the facility being able to be seen by at least one detector, with another 14% of the facility being able to be seen by one detector with the slightly delayed alarm, where it'll have to be a little bit bigger than 100 kilowatts before you see the fire. And finally, only about 5% of the facility will have no coverage. And if we go a little bit further here, what we can see is that in some of these cases, the fires are going to be in relatively low consequence areas. Like this area is very small. This area right here is in the middle of nowhere where there should be minimal potential, especially considering it's high off the ground. There should be minimal potential for a fire to be isolated right there. And we have some other gaps back here where any fires like right along this wall are either going to extend into a spot where we can and will see the fire, or they are going to be just the result of small isolated bits of trash that get knocked over. Like if this thing somehow drops its load and a little bit goes back here, that could somehow potentially catch on fire. Or we might see a little bit of low coverage when we have both this thing right here and the trash pile blocking both of these detectors. But when you consider that if we just go a little bit higher, we're going to get good coverage above that. So at that point, when we assume that these flames are going to have a certain height to them, there's a good chance that any fire that is just right there at deck level, we're going to see the flames poking up from behind the fire, the lower parts of the pile, unless this pile is substantially larger than what we're portraying here. And that's also one of the reasons why it's good to arguably have more detectors than you think you need, or have more within one detector looking at different angles of an object. That way you have some sensitivity, some robustness against uncertainties in the size of these piles and the locations of these pieces of equipment. And so that's just a quick look at how we can use HazMap3D to assess the coverage on optical flame detection in a waste disposal and sorting facility, similar to this one right here.